In this video and the next few videos, we are going to understand trigonometric functions at multiple and submultiple angles. So just to get a basic understanding of what multiple and submultiple are, so we are going to find formula of trigonometric functions at 2x, 3x, 4x. What I mean by that is we are going to identify formula of sine 2x, sine 3x or cos 2x or tan 2x, etc. Similarly, we are going to find formula of x by 2, x by 3, etc. So that is nothing but sine of x by 2 or sine x by 3, etc. So we are going to create formulas by using the understanding of trigonometric functions like the addition formula, which is sine of x plus y, or we are also going to use cos of x plus y, tan of x plus y, and find out what the multiple and submultiple angles would be. So let's get started and understand few important formula for cos 2x, sin 2x and tan 2x. So let us start with trying to find the trigonometric functions at 2x. So let us assume angle x is equal to y. So in this case, what we can do is sine of x plus y, we know that is equal to sin x cos y plus cos x sin y. Now if we apply x is equal to y, so we can get this as sin 2x, which is equal to sin x cos x plus cos x sin x, which is nothing but 2 times sin x cos x. So sin 2x, this is one of the first formulas. Sin 2x is equal to 2 sin x cos x. Now let's apply the same logic on the formula cos of x plus y, which is nothing but cos x cos y minus sin x sin y. Now we are going to replace y with x. So this is nothing but cos of 2x is equal to cos x times cos x minus sin x multiplied by sin x. So this is cos square x minus sin square x. So cos 2x, the basic formula we get is cos square x minus sin square x. Now we know that trigonometric identity, which is cos square x plus sin square x is equal to 1. So sin square x can be replaced as 1 minus cos square x. So in that case, cos 2x would be equal to cos square x minus 1 plus cos square x, or 2 cos square x minus 1. So this is another format of cos 2x. So now we have 3 formulas that we have found out. Now in this formula, let's replace cos square x with 1 minus sin square x using the trigonometric identity. So in that case, what would happen is cos 2x is 1 minus sin square x minus sin square x. We just replaced cos square x with 1 minus sin square x. So cos 2x is 1 minus 2 sin square x. So this is another format or another formula of cos 2x. Now let's move forward and try to find tan of 2x. So the formula we know is tan of x plus y is equal to tan x plus tan y, this divided by 1 minus tan x tan y. Now here we are going to apply x is equal to y. So this will be tan 2x is equal to 2 tan x by 1 minus tan square x. Let's try to identify the different formats of sine 2x. So we know that sine 2x is equal to 2 sine x cos x. So this can be written as 2 sine x cos x divided by 1. Now the trigonometric functions, one of the important identities is sine square x plus cos square x is equal to 1. So here we can change this to 2 sine x cos x divided by sine square x plus cos square x. Now let us divide both numerator and denominator by cos square x. Let us divide it. So the numerator will be 2 sine x cos x by cos square x. This whole thing divided by sine square x plus cos square x divided by cos square x. So here one of the cos x gets cancelled. So we would have 2 times tan x, that would be the numerator, and divided by, so here we can cancel cos square x, we would have 1 plus tan square x. So basically sine 2x can be changed to 2 tan x by 1 plus tan square x. Now similar way, let us try to find a different format of cos of 2x. So cos 2x is nothing but, we know that it is cos square x minus sine square x. Now this can be rewritten as cos square x minus sine square x divided by 1. We are applying the same logic, which is sine square x plus cos square x is equal to 1. Now how would we change this? So this will be cos square x minus sine square x divided by cos square x plus sine square x. Now we are dividing numerator and denominator both with cos square x. So the numerator would be, so cos square x here would be cancelled out. We would have 1 minus sine square x by cos square x is tan square x. So this will be divided by cos square x. Now similar way in the denominator we would have, so cos square x would get cancelled, we would have 1 plus tan square x. So this is nothing but a tangent format of cos of 2x. So please note down all this formula that we have understood so far. We will apply this in different problems so that we understand how to actually use this multiple angle formula. Now just to understand the formula we have gathered so far better, let's try to express these two questions in a tan x format. So the given information is sine 2 pi by 3 is of the format sine 2x. We have to express it in the form of tan x. Similarly, cos 2 pi by 3 is of the format cos 2x. We have to express it in the form of tan x. So let's start with the first one. So this is sine 2 pi by 3, which is following the format of sine 2x. So that means x is equal to pi by 3. Now the formula we understood so far is sine 2x is equal to 2 tan x by 1 plus tan square x, correct? So this is nothing but 2 times tan of pi by 3 divided by 1 plus tan square of pi by 3. So this is how we can express in the form of tan. Now similarly, let's try cos of 2 pi by 3. It follows the format of cos 2x. That means x is equal to pi by 3. Now cos of 2x is equal to 1 minus tan square x divided by 1 plus tan square x. So this is nothing but 1 minus tan square pi by 3 divided by 1 plus tan square pi by 3. So this is how we can apply multiple angles and convert it into different format. Now let's try to understand how to create formulas for submultiple angles. So here we have to find the formula for all the trigonometric functions we have learned so far at x by 2. So this is pretty simple. So how we can approach this is, we know that sine of 2x is equal to 2 times sin x times cos x. Now we have to replace x with x by 2. That is all we have to do. So in that case, what we would have is sine of 2 times x by 2 is equal to 2 times sin x by 2 times cos of x by 2. So we can cancel out the 2 here. So sin x is nothing but 2 sin x by 2 times cos of x by 2. So this is your first formula for sin x at x by 2. Now similarly, let's try the next one. We know that cos 2x is nothing but cos square x minus sin square x. Now let's replace x with x by 2. So here the 2 would get cancelled. So cos x is nothing but cos square of x by 2 minus sin square of x by 2. Now let's go to the next one, which is tan of 2x. Tan 2x is nothing but 2 tan x divided by 1 minus tan square x. Again, we are replacing x with x by 2. So this will be tan x, because the 2 would get cancelled. Tan x is equal to 2 times tan of x by 2 divided by 1 minus tan square x by 2. Now just to understand better formats of cos x, so we can just play around and have better formulas like different versions. For example, expressing cos in terms of tan, we know that cos 2x is equal to 1 minus tan square x by 1 plus tan square x. We just try to express cos in terms of tan. So if we are replacing x with x by 2, this will change to cos x because the 2's would get cancelled. So this will be 1 minus tan square x by 2 divided by 1 plus tan square x by 2. Now similarly, we can express sin 2x, right, in terms of tan, which is nothing but 2 times tan x by 1 plus tan square x. So we are replacing x with x by 2. So the 2 would get cancelled here. So we would have sin x is equal to 2 times tan x by 2 by 1 plus tan square x by 2. So these are the submultiple angle formulas that I would like you to note down in a separate formula sheet. So maintaining a formula sheet is really good. It helps you to quickly refer what formats we have actually found out, and we can apply it immediately. Now let's try to solve few problems so that you get a good grip on all these formula applications. Now before we start solving the problems, let us try 2 more variations of this formula. We just now learned that cos x is equal to 2 times cos square x by 2 minus 1. Now in this case, let's see what is the value of cos of x by 2. So here we can rearrange this equation to 2 cos square x by 2 is equal to 1 plus cos x, and cos square x by 2 is equal to 1 plus cos x by 2. So cos of x by 2 is equal to square root of 1 plus cos x by 2, and this can be a positive or a negative value. Now we know that in the first quadrant and in the fourth quadrant, cosine is positive. So depending on the angle and which quadrant it belongs to, we can determine whether it is positive or negative. So cosine is negative in the second and the third quadrant. So you can watch these videos in the trigonometric functions playlist. We have discussed in detail what these quadrants and how these angles are defined there. So this is one variation. We'll add all this to our formula sheet in some time. So now the next variation we want to understand is, we know that let's check, cos x is equal to, the sine format is 1 minus 2 sine square x by 2. So if we rearrange this, we would get 2 sine square x by 2 is equal to 1 minus cos x. So sine square x by 2 is equal to 1 minus cos x by 2, and sine, just a second, so sine x by 2 would be equal to plus or minus square root of 1 minus cos x by 2. Now sine is positive in the first and second quadrant. So depending on the angle, we can choose what sign the value will carry, and sine is negative in the third and fourth quadrant. So this is another variation of the formula. Sine of x by 2 is equal to plus or minus square root of 1 minus cos x by 2. Now just to understand what the another format is, it is not very significant. It is tan of x by 2, which is nothing but sine x by 2 divided by cos x by 2. We just divide it, we will end up with plus or minus 1 minus cos x divided by square root of 1 minus cos x by square root of 1 plus cos x. And here again, tangent or tan is positive in first and third quadrant. Tangent is positive, and in the second and fourth quadrant, tangent is negative. So this is one more variation of the formula. Now let us add all the formulas that we have learned to the formula sheet so that it is easier for you to refer and memorize these formulas, because we are going to apply this formula over and over again in the future videos in this playlist. So thank you for watching till now. Let's work on the formula sheet now. Thank you. Okay, here are the formulae that we learned up to this point. So I have listed down the formula we learned for trigonometric functions at 2x on the left side as well as at x by 2 on the right side. Please pause the video and make a note of these formula. Also try to memorize it. We are going to apply this formula in a lot of problems we are going to solve in the playlist. So please memorize it. Also maintain this formula sheet and go through these formula over and over again. So please pause the video and copy it. And thank you for watching till the end. I'll see you in the next video.